Hi and welcome. Today we're going to be talking about Simpson's rule. Is given above, and it's given by delta x over 3 divided by 3. Um, what is inside the parentheses is a little bit less traditional um, in that it starts with just f of x naught. That's given by x naught is just going to be a. Then we're going to increment the values of x, so x1 will be a plus delta x. Now, we evaluate the function at f of x1, but we multiply it by 4. Then the next time we multiply it by 2. Then the next time by 4. Then by 2. Then by 4. All the way until we get to f of xn. And it has to end in the pattern of 4, 2, 4, 1. Okay? So just be aware that what's inside the parentheses is always alternating between 4 and 2 except at f of x0 and f of xn. Those are the values. x0 will have the value of a, x sub n will have the value of b. The error bound for this, for Simpson's rule, is going to be given by k times b minus a to the 5th power divided by 180 times by n to the 4th. Now, in this example, we're going to use n equals 10 and approximate the integral from 0 to 2 of e to the x divided by 8 plus x squared. So let's just write out delta x. That's going to be b minus a divided by n. So that's going to be 0.2. Another piece of information that's useful is just to remember e to the x is f of x is what's inside the integral, which is e to the x divided by 8 plus x squared. Okay. At this point, we're going to proceed to calculate Simpson's rule. Okay. And Simpson's rule with n equals to 10 is given by this delta x, which is 0.2 divided by 3 times f of x0. F of x0 is just the point itself a, so in this case that's 0, plus f of 0.2 plus f of 0.4, and I forgot something very important, which is we have to remember the alternating pattern of 4, 2, 4, so the next one gets multiplied by 4, f of 0.6, then we have 2 times f of 0.8, then we have 4. If I increase this by delta x, that's going to be 1, plus 2 times f of, increase it by 0.2 is 1.2, plus 4 times f of, increase it by 0.2 will be 1.4. Each time I increase the value inside f, that is the x value, by delta x, which is 0.2. So now I do plus 2 times by f of 1.6 plus 4 times f of 1.8. Then, hey, now I get to f of 2, that's the endpoint b, so that's just f of x itself, which is going to be 2. Since that's the last point, I do not multiply it by a 4 or a 2, it's just f of 2, the endpoint. Now when I do this calculation, all of this needs to go into a calculator, okay? And to calculate f of 0.4, for example, I plug that into e to the x divided by 8 plus x squared. So that would be e to the 0.4 divided by 8 plus 0.4 squared. That would be f of 2. We put this into a calculator, and we're going to get 0.648. Okay, so that is our approximate value for this integral on 0 to 2. Now,